So today we will learn shear force diagram and bending moment diagram. We will start the topic shear force diagram and bending moment diagram. So at first we will start from this scratch level where we will see uh, different type of beam with supports. Like first one is simply supported beam. Okay, simply supported beam which is having one hinge and one roller support. Second one is fixed beam. Okay, both side are fixed. Third one is cantilever beam. So cantilever beam is one end is fixed and another end is free. So these three are the very important, and one more is there which is overhanging beam. One of the portion is overhanged right in the circle. This is overhanging beam. So another one, a special one is there which is called probed cantilever. One end is fixed, resting on a roller or a hinged support and overhanged. So this is probed cantilever beam. So these are the type of beams with supports. So now let's move to somewhere where which is very important, which is loading condition. Now this loading condition also very important. There are different loading conditions. With this loading condition only we can find out the diagram. So the first loading condition is point load. So this is point load which is acting at anywhere, whether it can be on middle or anywhere. And this one is UDL, uniformly distributed load. Okay, which is the load is distributing throughout the section or where the marking is done. Okay, now this one is UVL, means uniformly varying load, which is varying with the length. Means first it has some value, with the length it is decreasing or it is increasing. Okay, this is UVL, uniformly varying load. It is varying with the length. This one is moment. It can be anti-clockwise or clockwise. By observing the it is anti-clockwise or clockwise, we can change the signs. So let's move to shear force diagram. So how shear force diagram is drawn? Today we will learn this much only, how shear force diagram will drawn. Okay, so for different loading condition, how the shear force diagram will behave. Let's start the shear force diagram. So the first diagram we are drawing is a simply supported beam with a moment. Okay, so if simply supported beam with moment, the shear force diagram will be constant. Okay, throughout the length it will be constant. Now next move to a cantilever beam with point load at the free end. uh, the diagram will be again constant. That you have to remember. Okay, for cantilever beam for point load it is constant. Now let's draw another one which is simply supported beam having point load at the center. It will be again, it is constant in nature. So it is constant in nature. Whether it is positive or negative, you will find at the time of calculation only. So The next one is simply supported beam with UDL, uniformly distributed load. It is linear. Okay, so it is linear. Now uh, the next one is a simply supported beam with uniformly varying load. So this time the drawing will be parabolic. Okay, this time the drawing will be parabolic. As I said before, whether it is plus or minus, it will be known after calculation. Above the line it is plus, below the line it is minus. We will come when we'll do any numerical. This sign convention also I am going to do at the last of this video. Initially I am going with the drawings that you have to draw after calculation. That is, first you have to know. So at first I have done all the simply supported beams. Now this is the cantilever beam with point load. So cantilever beam with point load, it is constant as I have already mentioned, and a cantilever beam with UDL, it will be linear. Okay, it will be linear in nature. So these are the drawing that you have you should remember. First you should mug up. And in the case of moment with cantilever beam, there is no shear force diagram. Okay, there is zero, the line is zero. So now let's move to bending moment diagram. These diagrams are very important. Before you approach for any numerical, you have to know where and which diagram is going to use. Okay, for a bending moment diagram, what you have to do is same. At first let's take a simply supported beam. So simply supported beam with a moment, the drawing will be linear in nature. Okay, so there will be linear in nature. So in the drawing, in the first drawing, you have noticed that sudden change. So this change is called point of contraflexure. So this point of contraflexure, what is this point of contraflexure? Let's come into the next video. There are many short terms or short definitions are there which you have to know, and we will do it in next video. For now, this drawing you have to know. So for the second one, simply supported beam with UDL is parabolic. Simply supported beam with point load, it's linear. And simply supported beam with uniformly varying load, it is cubic parabola. Okay, it is third degree cubic parabola. So the degrees that I'm going to come in the next. So let's go to the cantilever beam part. So the first cantilever beam with point load at the free end, the for the bending moment, the drawing will be linear. Okay, the drawing will be linear. So these drawings are very important, as I have already said. Uh, the sign convention also is very important, whether it will be plus or minus. I'll discuss in next part. So cantilever beam with moment, the bending moment diagram will be constant. So cantilever beam with UDL, uniformly distributed load, it is parabolic. So this was the drawings that I have showed you. Now the trick is, if shear force is 0 degree, if someone says, or if in question the shear force is 0 degree, like it is constant, so the bending moment will be add 1 degree, means it will be 1 degree. 1 degree means linear. Okay. Okay, let's go for big examples. Let's finish it and go for big examples. Let's differentiate this shear force diagram and bending moment diagram. If says, if it is point load, the shear force will be 0 degree. 0 degree means constant, and bending moment is 1 degree. 1 degree means linear. Okay, these are the short tricks that you also can remember. So it can be like this. Okay, plus or minus, as I have said, uh, you can know when you are doing calculation. For UDL, uniformly distributed load, if shear force diagram is 1 degree, then bending moment diagram will be 2 degree. So 1 degree means it will be linear, obviously. So let's draw a linear one. Plus or minus, you will come to know. And for 2 degree, it will be parabolic. Okay. Then 2 degree for shear force diagram in the case of uniformly varying load, it is parabolic, and 3 degree is cubic parabola. Okay, the short trick was 0 degree for constant, 1 degree for linear, 2 degree for parabolic, and 3 degree for cubic parabola. Okay, so let's now move to sign convention, which is very important, and you also can write it down or note it down how I am doing this. Sign convention, it is very important. So let's go for sign convention. So in the case of sign convention, let's start with shear force. So what is shear force? First, you have to know what is shear force. A bookish definition of a shear force is what? It is a force which provides resistance against sliding. So a force which provides resistance against sliding. So how sign changes, or how we can say whether it is plus or minus, we can see by this drawing. So this is a trick drawing, you can say. So one is left, one is right. Left part is left, right part is right. Let's say your left hand is upward and right hand is downward, so it is positive. Okay, just remember, left hand up means positive, right hand up means negative. That is the thing. Right hand up is negative, and left hand up is positive. When this positive and negative, why the left hand or right hand is up or down, that we will come in the next video when we will do the numericals. That will be easier to understand. Now let's go for a bending moment. Bending moment is generally a resistance against bending. Yeah, it's a bookish definition. So how bending moment uh, sign changes? Okay, for hogging bending moment, let's go for sagging first. This one is sagging. So the for sagging bending moment, it is a positive. For hogging bending moment, obviously it will be negative. So sagging or hogging, you also can imagine by smiley ball. Let me draw it for you. Let me draw it for you. For sagging, This one is smiling. Okay. For hogging, this one is sad. Okay, sad face and smiling face. Okay, this was the video for today. The next will be definitely numerical. That will be helpful. Thank you so much.